Okay.
Okay, so what problem are you doing?
We're doing chapter A, problem 63.
Okay, so chapter A is very much all about momentum.
Yeah.
Yeah.
So any problem, we want to get momentum.
Alright.
Okay,
So
so-
the question asks, a neutron with a mass of 1.67 times 10 to the negative 27th kilograms and moving at a speed of 45 kilometers per second makes a head-on collision with a boron nucleus with a mass of 1.66 times 10 to the negative 26 kilograms. The boron nucleus is originally at rest. And then part A asks if the collision is completely inelastic so that the neutron and the boron nucleus stick together, what is the final kinetic energy of the system expressed as a fraction of the original kinetic energy? And then part B asks if the collision is completely elastic, what is the fraction of the nucleus, or neutron's original kinetic energy transferred to the boron nucleus? So, we're gonna wanna find the final velocity of the two in order to get,
Okay, so we want to sketch it first.
yeah.
This is gonna be before, and since it's the inelastic,
Yeah.
so
They'll be together.
what after is gonna be like this,
Yeah,
connecting.
same direction.
Mhm.
Wait, that one's N and that one's B. The first circle, right?
Yeah.
Okay.
There's a neutron and boron. Neutron and boron. And we want to know the kinetic energy. Final kinetic energy, we're gonna need the final.
Wait, and before, shouldn't you put that it's going in that direction? That the N, isn't it? Yeah.
It's gonna be going this direction.
Yeah, and then on the before, that's going in that direction, that one's at rest.
Yeah.
Okay.
So we're gonna need the kinetic energy. We're gonna need the final velocity. So our, the final kinetic energy is gonna equal to 1/2
MV squared.
mv squared. So what's that V? That V is the final velocity,
Oh,
right?
squared.
And M is the
Big N. So
Big
we're gonna
N
add
is
the two,
the
right?
two, yeah, the combination of mass of neutron and mass of boron.
So it's gonna be 1.67, so that's gonna equal
So the big M is what?
1.827
1.827
times 10 to the negative 26
times 10 to the negative 26
kilograms.
kilograms.
Okay, and then we just wanna find the big V.
Big V, we don't know.
Okay, so we
And
can use.
So now we have a bunch of initial stuff, and we want to find the final stuff. So I think of conservation momentum. So the conservation momentum is mn times velocity of initial velocity of neutron
An initial.
plus an initial
So M of B times VB.
VB initial. So the VB is initial is 0 because it's not moving. So we just get that, and that will equal the final velocity. The final momentum would be the mass, the big M,
Yeah.
because it's
Yeah,
an
the
elastic,
two.
times
V,
V, the big V,
final.
final. Alright.
Okay.
Since we know this, and we know this, we can solve for that.
Right. So the M times V for the neutron, I think that equals 7.515.
This right here will be, what was that?
7.515
7.515
times 10 to the negative 23rd.
times 10 to the negative 21 again?
23rd.
23rd.
And then that equals 1.827.
1.87, right?
Yeah, so big M.
So you know what, we're gonna save time and just divide this by the
Yeah.
big M.
And that's
Which is
gonna
right here.
equal 4,113 meters per second.
So the big V is, what was that again?
4,113.
4,113
4,000, yeah. Meters per second.
here per second.
So now I can solve for the final kinetic energy.
Yeah,
right?
let's stop for that.
And that's gonna.
So you squared that times this and divide by 2.
Right. Yep.
So what is
It's 1.546
1.546
times 10 to the negative 19
times negative 19.
kilograms per meter second
That'd be
squared.
joules, right?
Yeah.
Okay.
Alright.
So we want to put in a fraction of the over the original kinetic energy.
And
Since the boron was not moving,
We
it's
just
at
use
rest,
the neutrons.
and neutron, all we have to do is just find the initial kinetic energy of neutron.
Right.
So in order to find that, is 1/2 times the mass times square velocity.
And that's gonna equal 1.69 times 10 to the
1.69 times 10,
to negative 18.
18. But you guys, did you
Or
guys get
18,
this though?
19.
Did you guys catch this?
Yeah.
Because
but-
the given was in 45 kilometers
Yeah.
and
Gotta
I
change it.
change it into meters, yeah.
And that's gonna be 18, not 19, for 1.69.
Right here?
Yeah.
The fraction, we just will be 0.0914.
0.0914.
Yep.
Okay. Because the joule,
Here.
is there any unit right there?
No.
Why is
It's
that?
a fraction.
Yeah. So the joule, because the joule will cancel out?
Yeah.
So, all right then. So we're done with part A, and we move on to part B.
Yeah.
All right, so part 2, we have to find the, what was that again? The,
What
What
fraction of the neutron's original kinetic energy is transferred to the boron nucleus?
okay, we want to know how much kinetic energy transferred from the neutron nucleus to the boron after the collision. So this situation will be, this what happened after the collision. Since it's elastic, so the neutron will go this way, and the boron will go this way after the collision, and some of that energy will transfer to this boron energy in order for it to move. So we're gonna have to find the final velocity of neutron and the final velocity of boron. So in this case, you came up with the what was that again? The
Relative velocity.
the relative velocity of the relation, and which is, here's the equation, which is the final velocity of neutron minus final velocity of boron equals to the negative initial velocity of boron minus initial velocity of neutron. And we set it up right here, that we just put it in the reverse. If you guys didn't see it, it's right here. This is the initial velocity of neutron, right there. And since this negative and negative right here will cancel out, so it's all positive. And we got the final velocity of neutron and final velocity of boron. And since we have two variables
We
in
need
this
two
problem,
equations.
you need two equations in order to eliminate one. What equation you can come up with? And you guys came up with the what is it? The conservation of momentum. So the conservation of momentum is the initial momentum. It's right here, and the final momentum of boron, of neutron and boron right here. Since we only know the mass of both of them, but we don't know the velocity right there. Now we have two exact variables that we want to look for. So we set it up like that, right? And this kilograms right here will cancel out, right?
Right.
Because
Yeah.
we try to make things less complicated. And now we have to this right here. So we want to eliminate one of this equation in order to solve one of them. So what we want to do? So we want to eliminate one of these variables to solve for one, because we have two variables. So we set them equal right here. Yeah, like times this right here. This right here with times 1.67 times 10 to the negative 7 on all of this equation.
Right.
So we got it right here. Right there. So now the final velocity of
The neutron crosses, they cancel out.
this right here will cancel out.
So essentially, we're just solving for
Yeah.
the final velocity of boron.
Yeah, we add them up. No, we subtract them. Since this is positive, we subtract them. And since we subtract this right here, this is negative. Negative times negative is positive. Positive times positive is positive. So we got that right here.
And
We
then,
got 1.8 and equals to that right there. So yeah, we add this up right here. No, we subtract them.
no, we added them.
We added them? Yeah, we added them.
And then now to find the final velocity of the
Boron.
boron, we're gonna divide by 1.867, which then gives us
So we got it right here.
right there. And then now we can find the kinetic energy
Kinetic energy, the final kinetic energy of
of the
boron. So we find the kinetic energy of boron right here by, you got the final velocity times the mass, you square this times the mass divided by 2, you got that. Remember the kinetic energy formula, and you subtract it by, in order to find a fraction, the final, subtract initial, right there. So we have my answer is 0.3,
3, 2.
2,
3, 3, 2.
3, 2.
Yeah.
So it's the answer. You guys get that?
Yeah,
Yes.
isn't it, oh no, it
Yeah,
has.
because it's not joule, because the joule cancels out.
Yeah, it's a fraction, so it counts, okay.
Alright then.
All right.